In this video, you're going to learn a little bit about stoichiometry. Please take notes in your notebook as you watch this video. At the end of the video, there are going to be some questions that you need to answer. We're going to start by talking about parts of a chemical reaction. There are two key parts in a chemical reaction. At the back of the arrow, there are the reactants. The arrow points towards the products. This means that the reactants combine together in order to form the product. Reactions have to be balanced. So on this side, we have 2 atoms of hydrogen. So we have to end up with 2 atoms of hydrogen in the products. If we start with 2 atoms of oxygen, we have to end up with 2 atoms of oxygen in the product. This reaction is not balanced. We need to, therefore, balance it. So, because we need 2 atoms of oxygen, we have to add a 2 in front of the H2O. These big 2's, the coefficients, mean that we have 2 molecules of H2O. In one molecule of H2O, there are 2 hydrogens and 1 oxygen. But during the course of this reaction, 2 molecules of H2O will be formed. There are now 4 atoms of hydrogen in the reactants and 4 atoms of hydrogen in the product. There are 2 atoms of hydrogen in the reactant and 2 atoms of hydrogen in the product. This is called the law of conservation of mass. Mass can never be created or destroyed, so if we start with 2 atoms of oxygen, we have to end up with 2 atoms of oxygen. This reaction is also like a recipe. It's showing us that it takes 2 moles of H2O, 2 moles of H2, of hydrogen gas, in order to make 2 moles of H2O. These coefficients are called a molar ratio. It's a conversion factor. It's telling us that 2 moles of H2 can make 2 moles of water. So if we look at the different molar ratios, the ratio of H2 to O2 is 2 to 1. Notice we have a 2 coefficient, and no coefficient means a 1, just like the subscripts. No subscript means that we have 1 of these oxygens. So no coefficient means a 1. So the ratio of hydrogen gas to oxygen gas is a 2 to 1 ratio. 2 moles of H2 can react with 1 mole of oxygen. The ratio of H2 to H2O is 2 to 2. 2 moles of hydrogen gas can form 2 moles of water. If we look at oxygen and water, 1 mole of water can form 2 moles of, 1 mole of oxygen gas can form 2 moles of water. So, if there are 7 moles of hydrogen gas, how many moles of water can be made? So think about that ratio. We have 7 moles of hydrogen gas, and for every 2 moles of hydrogen gas, 2 moles of water can be formed. So, just like you have been doing with mole conversions, we set up an equation. We start with what we're given. We're given 2 moles of hydrogen gas. So we start with 2 moles of hydrogen gas, and then now we need to convert from hydrogen gas into water. So we look at this ratio, and we think, okay, if I have 2 moles of hydrogen gas, I can make 2 moles of water. So I start with 7 moles of H2, because that's my given, and now moles of H2 needs to go on the bottom so that my units cancel out, and I'm converting it into moles of H2O. So this means that for every 2 moles of H2O that are produced, it takes 2 moles of hydrogen gas. So then you do 7 times 2 divided by 2, and you get 7 moles of H2O. So let's try another one. How many moles of oxygen are needed to fully react with 4 moles of hydrogen? So now we're looking at the ratio of oxygen and hydrogen. We start with what we're given, 4 moles of hydrogen. And now, moles of hydrogen again needs to go on the bottom so we can cancel out that unit. And we have 1 mole of oxygen for every 2 moles of hydrogen. So in order to make this reaction go forward, we need 1 mole of oxygen for every 2 moles of hydrogen. So here's our 2 moles of hydrogen per 1 mole of oxygen. So then you go 4 moles of hydrogen gas times 1 mole of oxygen gas divided by 2 moles of hydrogen gas equals 2 moles of oxygen. This means that if we have 4 moles of hydrogen and we want to react completely all of that hydrogen, we need 2 moles of oxygen. So you need to try this in your notebook. Title the page Introduction to Stoichiometry Practice. And you should copy down this reaction. I want you to notice how this reaction is balanced. How many atoms of iron are on the reactant side? Does it match the number of atoms of iron on the products? What about carbon? We have 3 atoms of carbon on this side, on the reactant side. We have 3 atoms of carbon in the product. How many atoms of oxygen are on the reactant side? How many atoms of oxygen do we have on the product side? So you can prove to yourself, see if this is a balanced reaction. So the first question is to list 3 molar ratios. Remember, a molar ratio says how many moles of iron 3 oxide do we need in order to react with carbon. So think about how many of these have to react with how many of these. If you have an excess of iron 3 oxide, how many moles of carbon do you need to create 8 moles of iron? So you need to think about what's given, you need to think about what conversion factor you're going to use, and be sure to set it up so that you cross off your units. The other ones are pretty similar to this one. Again, how many moles of carbon dioxide would form if 16 moles of iron 3 oxide react completely? Think about what you're given, think about your molar ratio, what conversion factor you'll use, and set it up so that your units cancel out. How many moles of iron would form if 44 liters of carbon dioxide were released after the reaction? So in this presentation, we've only been talking about moles. So you're first going to have to convert from liters of carbon dioxide into moles of carbon dioxide, and then try and convert from moles of carbon dioxide into moles of iron. So here's our iron, and here's our carbon dioxide. Think about the molar ratio. And number 5 asks, if you have 82.6 grams of iron that formed during this reaction, how many grams of carbon were used? So how many grams of carbon were used in order to form 82.6 grams of iron?